Finally, let's briefly introduce alkene reactivity. We will talk more about alkane reactions next week, but for now we will just give some general rules. So alkanes have historically been called paraffins, and this word comes from the word affinity, indicating that that alkanes have very little affinity to react, so virtually without any affinity to react. Alkanes engage only in a handful of reactions, and most of these occur under highly forcing conditions. And so their absence of functional groups is clearly demonstrated in the absence of reactivity. But among the reactions they do engage in, combustion is certainly the most important by volume, because main use of alkanes is as fuels in petroleum and natural gas, and hence their combustion is important. So in general, CnH2n plus 2, which is the general formula of alkane, with oxygen should give us n molecules of CO2 and n plus 1 molecules of water. However, combustion is rarely complete. In fact, combustion is complete only when we have gaseous fuels, such as methane and so forth. And for liquid fuels, and especially solid fuels, it's rather incomplete. And so this is a very theoretical equation, because partially combusted organic compounds become volatile and they enter the atmosphere as well along. And hence a lot of pollution comes in combustion of gasoline. Second reaction that is used in the production of fuel is called cracking or hydrocracking, and this is a petroleum term, and basically the term actually describes the reaction very well. So what we're doing here is taking a long chain alkane. Now remember, if you remember from our previous topic, this is a C12 alkane, and those are not good as components of gasoline. They're good as components of jet fuel or so forth, but not gasoline itself. And so these can be treated at high temperatures with catalysts and hydrogen, and they will break into two smaller molecules, C5 and C7. Now these are both components of gasoline, and so they work just fine. So basically when they converted something that is not so valuable into something that is much more valuable. This reaction can also be done without hydrogen, but still with heating and catalyst, to produce unsaturated molecule, because we don't have no hydrogen there. And these are now valuable in gasoline. The final reaction, this is the one that we'll just skim over because we'll talk in much more depth about it next week, is halogenation. And unlike the first two reactions, which thrive on heat, halogenation is actually using light, and so halogenation of methane with chlorine would give us chloromethane and HCl. Now this reaction is actually very useful because this is a reaction which introduces a functional group, this chlorine, into an alkane. And this really opens the door for a whole variety of other organic compounds which can be prepared from this chloromethane. That is of course not the case with combustion because it's completely uncontrollable and we just generate CO2. And it's not so much the case for cracking because it's a highly specialized reaction which occurs at high temperature, and it gives us a mixture of compounds which is not desired. So again, we'll talk about halogenation much more in many more chapters, but for now this is it. Thank you for today.